Bismillahirrahmanirrahim. Welcome to the second part of this topic, which is speaking about the power series. And we define the power series as a sum of, or just a sigma of Cn multiplied by x minus a to power n. And in the last part, we spoke about the radius of convergence and interval of convergence for the power series. And we said that for the power series, we have three cases. The series will be convergent only when x equal to a. And we mentioned this is if the limit of the ratio test goes to infinity, the limit goes to infinity, then we have the convergence is only for one case when x equal to a. The second case, if the limit is equal to 0, then we can say the series converges for all x. And when the limit, the third case, is equal to L multiplied by x minus a. In the third case, then we'll find some positive r for which that x minus a is convergent if it is less than r, and if it is greater than r, then the series will be divergent. And to give more detail about these cases, let's have some examples. Suppose that we have this series and we need to find the radius of convergence and interval of convergence for the given series. I have sigma n equal to 0 to infinity of minus 3 to power n x to power n divided by square root of n plus 1. Now to find the radius of convergence and also interval of convergence, we need to apply the ratio test. So this is an, and if we apply the ratio test, which is absolute value of an plus 1 divided by an is equal to minus 3 to power n plus 1 multiplied by x to power n plus 1 divided by square root of n plus 1 plus 1. We just replace n by n plus 1. Divided by an means multiplied by the reciprocal of the fraction there. That will be square root of n plus 1 divided by minus 3 to power n times x to power n. Simplify this, I will have x to power n plus 1 times x to power, divided by x to power n will be only x. And minus 3 to power n, with minus 3 to power n, I will have only minus 3. So this is equal to minus 3 multiplied by x times square root of n plus 1 divided by square root of n plus 2. Now the limit for this fraction, the limit, I will write it as square root of, I can write it as 1 square root multiplied by minus 3x as n goes to infinity. But we know that the limit for this one is equal to 1. So I will have minus 3, or I can take the minus 3 outside, will be 3 absolute value of x. Now by the ratio test, this is convergent if it is less than 1. By the definition of the ratio test, we have that the power series or the series will be convergent if it is less than 1, which means absolute value of x will be less than 1/3. 1/3, this is my radius of convergence. So r is equal to 1/3. This is radius of convergence. Now to find the interval of convergence, I have absolute value of x is less than 1/3. So I will get x will be greater than minus 1/3 and less than 1/3. So the interval will be between minus 1/3 and 1/3. So the interval will be minus 1/3, negative 1/3, and positive 1/3. But we have one thing more. I need to check the endpoint. As we did before, for some cases, the endpoint is included. So if we replace x by minus 1/3, or let's start with the first one. If x equal to 1/3, I will have sigma of minus 3 to power n multiplied by x, which is minus 1/3 to power n, divided by the square root of n plus 1. But this minus 3 to power n will cancel minus 3 to power n. I will have only, then I will have this is equal to 1/3 or only square root of 1 over square root of n plus 1. So it will be 1 over square root of n plus 1. But this series is divergent. This divergence by the b power series. Now for the other endpoint, number 2, if x equal to 1/3, then we'll have minus 3 to power n 1 over 3 to power n. We just replace x by 1/3 divided by square root of n plus 1. This is equal to sigma of minus 1 to power n divided by square root of n plus 1. But this one, by the alternative series test, it is convergent. So it means the interval of convergence now will be open minus 1/3 and close from positive 1/3. So this is the interval of convergence. For convergence. So again, to find the radius of convergence, we need to apply the ratio test, find the limit. If the limit is equal to only absolute value of x minus a less than some number, then we can take that number to be the radius of convergence, and from which we can find the interval of convergence. If the limit goes to infinity, then the series will be converged only for x equal to a, and in that case, the r is equal to 0. And if it is equal to, if the limit is equal to 0, then the radius of convergence will be infinity. It can be for any values for x. For example, in the second example, so let's apply the ratio test to find the convergence or the radius of convergence and the interval of convergence. By the ratio test, make it quick, this will be a plus 1 divided by an. which is equal to, it will be n plus 1, replace n by n plus 1 multiplied by x plus 2 to power n plus 1 divided by 3 to power n plus 2 to the plus 1 plus 1 multiplied by an, just write it upside down, it will be 3 to power n plus 1 divided by n times x plus 2 to power n. We simplify this one, we'll have absolute value of this x plus 2 times n plus 1 will cancel this x plus 2 to power n. And the 3 to power n plus 1 will cancel 3 n plus 1, so I will have 1 over 3 down. In the denominator, I will have 3 multiplied by n. For the numerator, I will have n plus 1 multiplied by x plus 2. So this can be written, or if you take the limit, I will have limit of n plus 1 divided by n, or 3n, we can say, multiplied by x plus 2. As n goes to infinity. Take the highest power, this n will cancel this, I will have only 1/3. So this is equal to 1/3 multiplied by x minus 2. So it is 1/3 x plus 2. Now this one will be convergent. If 1/3 times x minus 2 is less than 1, or if you multiply by 3, we can write it as x minus 2 less than 3. It means r is equal to 3. So the radius of convergence is r equal to 3. Now for the interval, we can find of convergence. I will solve the inequality. It is minus 3 less than x minus 2 less than positive 3. If we add 2 to the left-hand side and right-hand side, this is plus 2 and plus 2. I will have minus 1 less than x less than 5. That is between minus 1 and 5. But also in this case, I need to check the endpoints. So check the endpoint when x equal to minus 1, or the endpoints. If x equal to minus 1, the series will be, we go back to see it, replace x by minus 1. So minus 1 plus 2 will give me 1. That will be n. Will be n multiplied by 1 to power n divided by 3 to power n plus 1. Which is sigma divided by 3n plus 1. And this series can be tested for the convergence using one of the tests to check whether it is convergent or not. But we will see that this series is divergent. So it is divergent. Concluded this mistake should be this is plus. This is plus means this one is negative. I did mistake in this one. Minus 2, minus 2. So it will be between minus 5 and 1. So for this one, I have to change this to be minus 5. I do it again. If x equal to minus 5, again, this mistake is because it is plus, not minus. Yeah. So when x equal to minus 5, then we'll have n multiplied by minus 3 to power n divided by 3 to power n plus 1. This will be minus 1 to power n times n divided by 3. But this is by the divergence theorem. This is divergence, which means x minus 5 is not included. For the other endpoint, now for x equal to 1, we have sigma of n multiplied by 3 to power n divided by 3 to power n plus 1. That will be again sigma of 3 or n divided by 3. Because also this is divergence or divergence. So the endpoints are not included or not part of the interval of convergence. So the interval of convergence will be with open interval minus 5 to 1. So again, to check the convergence or to find the radius of convergence, we apply the ratio test. We find the limit and we find that the limit is equal to 1/3 x plus 2, and that will be convergence if it is less than 1, from which we found the radius of convergence, which is x plus 2 is less than 3. And the interval, if we solve the inequality, x plus 2 will be between minus 3 and 2, and that will give me minus 5 less than x less than 1. And to find the interval, we need to check the endpoint. When x equal to minus 5, we found that this series is divergent, which means minus 5 is not included in the interval of convergence. And the other endpoint, x equal to 1. And if we replace x by 1, we will have the series n divided by 3, which is also divergent, which means also the x equal to 1 is not included in the interval of convergence. So we conclude that the interval of convergence is open interval between minus 5 and 1.